what's the quotient rule? What happens if we take the derivative of f of x divided by g of x? Well, it turns out it's very much like the product rule. You take the derivative of the first function, f prime of x, and multiply by the second function left alone. Now, since g of x is in the denominator here, and think about the idea that 1 over x can be written as x to the negative 1. And we have our derivative rule for powers, like x to the negative 1. The rule is bring the power down and then reduce that power by 1. So I get negative 1 x to the negative 2, or I could say that's negative 1 over x squared. And so this basically happens to g because it's in the denominator. So what happens next up here is I get a minus where I leave f alone, like the product rule, and multiply by g prime of x. Now again, because g is in the bottom here, it's kind of trapped in this rule too. That's why we get the negative here. And then this square of the denominator pops in. So down here, I have to square whatever g was in the denominator. So that's the new twisty tie that gets in here. It's like the product rule, where we have the derivative of one function times the first, the derivative of the other function times the first, and then we have to subtract because one of the functions was in the denominator related to a negative power, and then we have to divide by the square of the denominator. Okay. And then when I was in calculus, I had a teacher that had kind of a little song about this. I'm not going to sing it because I'm a horrible singer. But the way he looked at it is there was a high function, let's call it h of x, and a low function. Let's call that L of x. That's an L right there. Make it a little scripty L. So here's my high function, and here's my low function. And so his version of this was that you get low d high, right, derivative of the high function, minus high d low, all divided by low squared. So again, his little song was low d high minus high d low over low squared. So maybe that little sing-song version will help you remember it. What helps me remember it is the idea that if something is in the denominator, we can rewrite it with a negative power. And if we take the derivative of a negative power, we get a negative multiple. So that when I take the derivative of the denominator, it has to go with the minus. So that's kind of my remembrance there to get this right, that the minus has to go with the derivative of the denominator there with g prime. All right, so let's test it out on a relatively easy function, and then we'll try it, some more examples of it. So let's see, easy function would be something we could do another way to just test it out. So what if I had the derivative with respect to x of 2x squared plus 3x over x? So a note on that, I could do the division by x before I take the derivative. So that would just give me 2x plus 3, and that's a pretty damn easy derivative to take, right? The rate of change of that line, the slope of that line is just 2. But we're going to try the quotient rule on this messier version. All right, so according to the quotient rule, it says take the derivative of the numerator first. So what's the derivative of 2x squared plus 3? Well, the derivative of x squared is 2x, times 2 is going to give me a 4x. And then the derivative of 3x is just 3. And then I'm supposed to multiply that by the denominator as is. And then minus, leave the first function alone, and then multiply by the derivative of the bottom, and the derivative of x is just 1. Right? The slope of y equals x is 1. Derivative of the slope function. And then I have to divide all of that by the denominator squared, which is just x squared. And my claim is that this crazy mess here is going to simplify to 2, because I believe in the quotient rule. I believe. All right, so distribute, bing, bing. That's going to give me 4x squared plus 3x. And then here I have to distribute the minus. So that would be a minus 2x squared minus 3. All of that is going to be divided by x squared. And then in the numerator, you should notice that we have 4x squared minus 2x squared, which is 2x squared. And then I have a 3x. Oops, I made a little note error there. That should be a 3x right there, right, from this term there. So I have a 3x minus 3x, which is a 0. So these guys are 0. So I just have 2x in the numerator. I divide that by x squared, and I get 2 like I claimed above. So why did I do it that messy way? I'm just showing that the quotient rule works. Another moral like before, if you can do algebra first and differentiate a simpler function, by all means do it. Okay, cool, nice, moving on.